Hello, my smart students. How are you doing today? Welcome once again to Dr. Saurav's classes. We were continuing our videos on subgroups, right? Okay, and today's topic we are going to talk on the index of a subgroup. What is the index? All right, of a subgroup. All right, today we are going to talk on this part. So let's go ahead and start. It says that let G be a group and H be a subgroup of G. Okay, so H is already an SG of group G. Of group G. Let me just get a thicker pen here. Group G. Yeah. Then the number of right or left cosets of H in G is denoted by H is to G. I just want you to understand this, that the number of right cosets to the number of left cosets is given as G is to H. Okay. Next part. For any subgroup H of a finite group G, order of G is equal to order of H. If you have a finite subgroup, okay, if you have a finite subgroup, okay, H of a finite group G, of a finite group G, then what happens is the order of G will be equals to the order of H. Okay, in G is to H. Okay, that means there is a one-to-one map between the sets of all the left cosets of H in G and the sets of all the right cosets of G. Okay, there is a one-to-one mapping, my students. There is a one-to-one, there will be a one-to-one mapping. That's what it's trying to say, one-to-one mapping. Okay, between all the left cosets in H of H in G and all the sets of all the right cosets of H in G. That means there will be a one-to-one mapping. Like if you draw the set type, one-to-one mapping. Okay, one-to-one mapping. Okay, moving on to our next point. Abelian group. My God, what an important topic this is. You don't even have an idea. What is an abelian group? You see, you will have multiple questions, okay, talking about, prove this is an abelian group, prove that is an abelian group. Okay, so you might want to go through this one. Very, very important. Very, very important. What does it say? A group G is called abelian if it satisfies the commutative property. So it satisfies all three properties. First one is closure. Second one is your associativity. Right, associativity is the criteria for the group. Third one is the identity. And the fourth one is the existence of an inverse, of an INV inverse. Now if you have another one, fifth one, that is this, okay, that is AB is equal to BA for all A comma B belonging to G, then that group G comma star is abelian, group. Okay, it's called an abelian group if it follows the commutative property. You know this property very well, commutative. right? What is the commutative property with addition? A plus B is equal to B plus A. What is the commutative property with multiplication? A dot B is equal to B dot A. Of course, FFCOURSE, of course, okay, A comma B will belong to the group G. Alright, when this happens, then it is an abelian group. Mind you, students, there will be questions, okay, that there is a group, there will be some type of a group given to you, okay. Let's say if I am to give you a simple example, okay, so what will I give you? Let's see. Okay, so let's think, like, what example can I give you? Let's say I got one in my mind, that's jumping about. That's, let's say, Z4. Yeah, Z4 with elements like 0, 1, 2 and 3. If I use these elements, okay, now just let me just rub out these things. Okay, the properties of a group, so I don't need to write it every time. You already have studied in the previous videos if you are watching what's going on, okay, and if you are paying attention as to what's happening, then you already know. So let's just give you a quick example on what's happening. Like if you have Z4 and if it's a addition modulo 4, okay, then if I make this quickly 4, so I have 0, 1, 2 and 3, right? So here also 0, 1, 2 and 3. Now if I do a normal addition on this, then you will see how the group becomes abelian. Okay, not necessarily it will be only with multiplication, with addition also it can be abelian. Okay, A plus B also it can give you. So you can see over here, let's add 0 plus 0, 0, 0 plus 1, 1, 0 plus 2 is 2, 0 plus 3 is 3. 1 plus 0, 1, 1 plus 1, 2, 2 plus 1, 1 plus 2 is 3, here this 1 here and 2 here. 3 and 1 plus 3 is 4, that will give you 0. 2 plus 0, 2, 2 plus 1, 3, 2 plus 2, 4, 0, 3 plus 2, 5, that is 1, because of course 5 minus 4 will give you 1. So you're supposed to get within. You know what the modulo 4 means. Modulo 4 means you cannot go beyond the number 4, okay. You have to be within the range of 4. So all the elements that you can see in this, even in the column wise, this, they should all be 4, 4, 4. Okay, then 3 plus 0, 3, 3 plus 1, 4, 0, then 3 plus 2, 5, 1, 3 plus 3, 6, 2. Now if you check if it's abelian or not, take elements A equal to 1 and B equal to 2. So first check 1 from here and 2 from it. Let's use another color. 1 from here and 2 from here. What are you getting? You're getting as 1 plus 2 as in 3. Now if you take 2 from here and 1 from here, you see you're still getting a 3, right? Here also 3, here also 3. So 2 plus 1 is equal to 3. So you can write A plus B is equal to B plus A. So it is following the commutative property. And mind you, this Z4 is a group, okay, plus it is a group. So if it is following the commutative property, then Z4 is an abelian group. Abelian group, GR. Alright, very simple concept, students. If a group follows a certain commutative property, if the group follows the commutative property, then it is called abelian. It can be A dot B into B dot A equals to, B dot A, or it can be A plus B. Let's not write there because it's not fitting. So, or it will be your A plus B equals to B plus A. Okay, any one of them will make the group abelian. Okay, so you don't need to worry about that. Alright, so students, today we learned about index of a subgroup, how the index of a subgroup is formed. Okay, then we learned about abelian group. Okay, how a group is called abelian, very very important. I told you this part, what is an abelian group. You might want to keep this in your head. Okay, and note all the notes down in your book. Okay, so that's enough for this part of the video, students. You keep taking as much help as possible, because all the help that you'll be needing will be provided here at Saurabh Sir's classes. Thank you very much, students. We shall do this video in the next part.